Thank you for saving me. So thank you everyone for coming down today. I hope you do not have coma induced by food. It's what I call a food coma after lunch. Okay, so today I'll be presenting something which is temporal analytics with discourse analysis. We're trying to trace ideas and the impact of these ideas on communal discourse. So my name is Alwyn. We are from NTU, Nanyang Technological University from Singapore. So let's say, imagine you are a teacher, facilitator using online discussion platforms to conduct activities with your students. So by the end of activity, you have a lot of posts, a lot of forum discussion posts. How do you actually analyze communal discourse and measure the students' level of understanding? How do you actually pick up key ideas relevant to the understanding and examine the impact of these ideas on discourse? And do the whole thing, everything, without being overwhelmed by the sheer amount of content and posts and any digressing talk that happens in discourse. So some of the research problems we have is that people want to monitor, analyze, and also gauge the level of understanding in the discourse without being overwhelmed by the large amount of posts. Also, we want to uncover key and promising ideas in discourse, and also to help them sustain their level of engagement so as to improve their ideas in discourse. And we want to measure and understand quality of ideas, which is a non-trivial process due to the complexity of idea itself. Tedious and challenging process to actually do this and to analyze text and discourse. So we want to identify and analyze promising ideas in communal discourse to advance communal knowledge. Last not least, we need to also manage efficiently the teacher's teaching resources and time. So what can be done? We want to identify promising ideas within discourse and assess the improvability of ideas through knowledge-building discourse. This is our focus in this study, and we also want to automate the analysis of such ideas in online discourse. But what can we harness? We can actually use online discussion platforms, which are actually aplenty, and also we can use analysis toolkits for discourse analysis. Last not least, we have the data analytics, or actually what is also known as big data analytics. Our goal in this study is to actually check out and also explore how we can use temporal analytics to assist with discourse analysis, to trace and to understand the impact of this, how do you use the impact on discourse to gauge students' and communities' level of understanding. So some background information on what I'll be introducing within this study. Online discourse analysis is actually discourse analysis done on an online forum. So it's a framework and means of exploring the implications between language and social institutional practices. And we are doing it on an online learning environment. Our study actually uses knowledge-building discourse and a platform that's called Knowledge Forum. So this Knowledge Forum is actually an online discussion forum that has knowledge-building scaffolds. More on it, we are actually looking at identifying and tracing promising ideas. So groups of keywords are actually representative of ideas in this study. We recognize and understand it, and also try to identify and trace the ideas within the discourse. The final goal is actually to find ideas that are promising to the collective advancement of communal knowledge. So some of the methods I'll be looking at: keywords and text mining. We want to extract the information from unstructured data, which is textual data in forums. And then from this textual data, we try to obtain features such as keywords. We'll use social network analysis. We try to provide insights into the mapping and measurement of relationships and flows between the nodes in the network, and also try to understand basic kind of social network measures such as degree, betweenness, and also centrality. Last not least, we'll use temporal analytics. So it's actually an analysis of data over time, and we plot frames of data over time so as to understand and discover patterns, and to possibly also do predictions of students' behaviors in discussion forums. So one of the platforms that we use is actually a KBDEX, which is a knowledge-building discourse explorer. So there's KBDEX for social network analysis. So this program is actually done by Jun Oshima. We are using it actually for one of our studies. So it's actually split into 4 different kinds of networks and views. On the top left, you see there's a discourse viewer. That's where we break down conversation into multiple turns. So let's say I'm talking and someone else is talking too, and then when this is broken down into discrete events. Mine is first turn, and the other person is the second turn, and so on. So that's how I break it down in a discourse viewer. On the top right is a student network. These are actually the agents within a network. And bottom left is a discourse unit network, which is actually the network of forum posts. Bottom right are keywords that we actually find out using a text miner. Last but not least, you look at the bottom, there's actually a bipartite graph, which is the graph that's running with all these elements in it. And this is not actually shown in KBDex, but this is also what is being used for calculation of social network measures. So a bit of information on the measure that we actually use, which is actually betweenness centrality, BC for short, which we'll be using for the whole presentation. So let's say you have nodes C and D in the middle of this network. So they are important mediators within a network. And if, let's say, A and F, or let's say B and E, make use of this C and D more often than any other nodes in the network, nodes C and D actually do possess very high BC. So we use a normalized BC equation because we want to actually measure relative values when the amount of nodes within the discourse actually increase over time, so that the values do not actually become very minimal when there are large numbers of nodes, forums, or any other data. So we look at BC trends because we want to look at how the value of BC for different nodes within a whole network is being influenced and how does it actually change over time. And then the attributes of promising ideas within discourse and how they relate to the trends themselves. So the first one is actually relevancy of the post and also the content towards the context of the discourse itself. So for example, you can have a very high BC trend. It can be a very high literal absolute value. And you can also have a trend which has very little values. Then it roughly shows that there's actually more relevance or actually a lesser relevance. This is one of the attributes. Second attribute is actually about interest. So this is communal interest from the community itself. Interesting data, interesting BC trends, they will have something which is on the left, you can see it's interesting. On the right is an example of something which might be uninteresting. So these are actually sample simulated data to show you examples of what we could predict. And last but not least is impact. So over the entire period of discourse, if let's say the trend actually exhibits a certain kind of unique behavior, this is actually something that actually shows that this post or these ideas within the discourse unit can have an impact on other kinds of discourse units within the discourse itself. So we talk a bit on our methodology. It consists of 3 parts, which is text mining, social network analysis, and temporal analysis. So firstly, we do text mining. We try to identify conceptual keywords which are related and also being used according to the context within that we're trying to teach. We use a text miner based on frequency counts and also an inbuilt thesaurus that filters stop words and pronouns such as the, you, me. So all these kind of words are actually not very useful in a way, but we're trying to find conceptual keywords, and therefore we're using a thesaurus to actually filter out these prepositions and adverbs. Next, we take these keywords and then we feed them into the social network analysis. So using KBDex, which was shown previously, we actually construct bipartite graphs, and then these graphs actually relates discourse units with the keywords themselves. And then from the discourse unit network, we obtain network measures such as betweenness centrality, which is BC. So the last part, we do a temporal analysis. That's where we actually detect the temporal BC trends and patterns indicative of promising ideas within discourse. We further track and trace the origins of these promising ideas so we can actually understand where is the origins, how does the ideas actually evolve, continue to sustain within a discourse, or fade over time. And we try to verify these promising ideas using qualitative analysis. So we'll be showing a few examples of this. Data and setting, we actually extracted the discourse data from a graduate level course of 13 in-service teachers and 2 staff. So the discourse actually conducted over 13 weeks of instructions, which is actually 1 full semester in Singapore. And then we have 281 knowledge forum notes, which are actually what we call a discourse unit. So these are like 281 forum posts. It is actually situated in a knowledge building discourse, which is and situated within a knowledge building environment. We have the knowledge forum as the discussion platform. And then there are inbuilt scaffolds for conducting knowledge building and building on knowledge of each other. And the team that we have for this course is actually a computer-supported collaborative learning, CSCL, and knowledge building principles. So during the course, the students were actually encouraged to communicate and share information using this asynchronous discussion platform, so they can actually share their information, they can be able to contribute and also build on each other's knowledge over time, anywhere and anytime. So it's actually a very convenient way for students to communicate and share their ideas with each other. So some of the results that we have here, we start with a text miner. We actually found a list of keywords within this course. These are some of the keywords that we found. And we constructed a network graph of relationships between keywords that are text mined from the discourse itself. What we realized was that commonly there are a few words like knowledge, knowledge building, knowledge, communities, learning, understanding. These are always linked together. And because some of the principles are actually not visible in this view, which we actually set quite a high threshold, we actually blow it up, and you can actually see there is a lot of other words within this course itself. And the rectangular box that you see there, that's actually an estimated size of what the figure on the left will take up, the space that you take up if you put it in an expanded graph. So we actually do a comparison between these two forms of approaches for text mining. What we want to say is that you can do text mining, but if you want to find out what key relationships are useful and also what conceptual keywords are actually useful for understanding ideas within this course, you have to strike a balance between these two. The one on the left, it can provide you with a few keywords which are actually important, but you might miss out on some small ideas that could be promising, yet still be left out because it's less discussed or less understood by the students due to unfamiliarity with the context, and therefore you don't see on the left. But whereas on the right, with an expanded graph, you get everything, but there's just not enough resources for you to just investigate every single node. And so we strike a balance by looking at the BC trends, which actually provides us with a more visible method of identifying promising ideas. So the temporal analysis of discourse actually allows us to look at the promising ideas in discourse in a more visible manner in this form. So what you're looking at is the normalized BC values in the y-axis and the number of elapsed discourse terms in the x-axis. That means as discourse progress, the values actually move from left to right. And these are three of the BC trends that we have extracted, which are actually exhibiting unique BC trends. So we want to show that DU8, 18, and 66, which are the three discourse units we have here, are actually frequently engaged by the community. They are consistently gathering communal interest for future discussions and also expected to contain promising ideas that can be built on by other participants themselves, just based on the BC trends itself. So once we find the BC trends and also promising ideas, we want to know how did these ideas evolve or how did they come about. And then we want to also know the impact of these ideas on discourse itself. So looking at this graph, you can see that some of the ideas and the discourse unit itself actually initiated much earlier, did not have much activities, and they suddenly have a very major relative spike later in discourse. Or they can also initiate and have a very big spike right at the start of the discourse. At the start of introduction of the discourse unit. So let's say we look at the one on the left. Let's say we look at both phases. So we split the analysis into two phases. The first phase is actually quite easy to identify. It's where the discourse unit is being introduced into the discourse. The second phase is the one which is relatively harder to find because we want to know how does the idea actually change and also impact other ideas within discourse. So you can see one is actually easy to see, number two is actually harder to find. So based on these two phases of analysis, you can see that the blue line, DU8, has initial low communal usage and interest. It has delayed pickup in the BC values and therefore can indicate that there's a possible return of interest by the community only later during discourse. Whereas for the one on the right, BC trend of DU66, orange dotted line, there are significant communal uptake and interest after initiation of the discourse unit. So it can represent novelty of ideas that have yet to appear in discourse. but it can also mean that there's consolidation and reinforcement of previously mentioned ideas within the discourse itself. So it could mean either thing. So do not be too scared of the wall of text on the left, because I've analyzed it on the right for you. So analysis of content, the ones on the left is for interested learners listeners who want to read what the students write. So it's actually quite a lot of stuff. Okay, so the analysis of the content is this. It's actually a response to generic questions that were posed in a discourse, and general concepts were described with details using examples itself about principles of knowledge building. So the significance of this thing is that it is a well-written note, initially uninteresting to the community due to its unfamiliarity with the meta-knowledge in the early stages of discourse. This is actually quite common in classes. And the subsequent inquiries, which are later discourse units, they are actually required for further explanation of what's going on in this early discourse unit with DU8. So in comparison, other students' discourse units were unable to adequately address inquiries as clearly as DU8 itself. And so students who actually start to propose inquiries in later stages of the discourse actually retrospectively make references to this early previous DU, which is this DU8, for clarifications. Therefore, it results in a delayed upswing of the BC trend itself. So that explains qualitatively what our BC trends was able to show us earlier in this study. So after looking at the blue line, we look at the orange line, also another wall of text. And on the right, the differences in processes of knowledge sharing and knowledge building were pointed out by the student, and there were thought-invoking questions. So these thought-invoking questions were used to invoke further discussions and debates among the students themselves. So what's the significance? There's an uptake in communal interest and also usage from the moment that a DU was introduced. So what this means is that ideas within DU were actually results of deeper analysis built onto an earlier discourse unit in DU25 by the same student itself. So the same student actually conducted additional research to actually understand a topic in their own capacity before coming back and posting it on a knowledge forum. And this discourse unit itself is actually very lengthy, but there were lots of other summarizations in it, and it's used as a report of what they found out to the community, and in hope that they can challenge the community to actually further discuss and also investigate promising ideas in the discourse unit itself. So a summary of our findings through this study itself is that we have a current issue whereby large class sizes and massive amount of content online, but how do you actually deal with it? How do you tackle this data? So learners unknowingly spend too much time on irrelevant ideas, which is why we are looking at promising ideas that teachers and students can focus on and actually help to advance communal knowledge. And understanding of ideas is actually a very tedious and complex process. Ideas itself